You know, when we think about software quality, it's easy to just ask a simple question. Does it work or is it broken? But the reality, as you probably know, is so much more complicated than that. Today, we're going to dive into what I'm calling the two distinct worlds of software quality, because really understanding both is the secret to building software that people actually love to use.
Ah, yes. We've all been there, right? We've all heard it, or maybe even said it. It is the classic developer get out of jail free card. The code works absolutely perfectly in the nice, safe, cozy environment of their own computer, but then you push it out into the real world and it's a completely different story. This one little phrase, honestly, it perfectly captures the central conflict we're talking about.
So, this brings us right to the heart of it. When we say a piece of software works, what are we actually saying? What are we measuring? As it turns out, there are two very, very different but equally critical answers to that question. Okay, let's start with world number one. This is the one we're all pretty familiar with. It's the world of features and functions and, just doing what it says on the tin. Did the button do the thing it was supposed to do? This is the realm of what we call functional testing. This slide really just frames our whole conversation perfectly. On one side, you have functional testing, which asks, what does the system do? Its job is to find bugs. But on the other side, you've got non-functional testing, which asks a totally different question. How well does it do it? And that's all about verifying quality. See the difference? Two simple questions, two completely different mindsets. So let's get a bit more formal for a second. The official definition here really nails it. Functional testing is all about checking the software against its design, its requirements. You basically have a checklist of things it's supposed to do, and you just methodically go through and check every single one. Simple as that. And of course, this isn't just one big monolithic test. It's actually built in layers. It all starts small with unit testing. That's where you check tiny, individual pieces of code all by themselves. Then you move up to integration testing, where you start to see if all those little pieces play nicely together. And finally, you have system testing, which looks at the whole application, the whole shebang, to make sure it delivers on its promises. Each layer just builds on the one before it. But, even in this very logical, straightforward world of functional testing, there is a particularly nasty, frustrating type of bug. It's like a ghost that haunts developers by breaking things that were working perfectly fine just yesterday. It's called a regression defect, and it's just the worst. You add a cool new feature or you fix a totally different bug and bam, suddenly some completely unrelated part of the app that has worked for months just breaks. The key word here is regression. You've actually gone backwards. And this is where the real damage happens. It's not just a technical problem. As this quote points out, regressions absolutely destroy user trust. I mean, we all have this basic assumption that something that worked yesterday is going to work today. When that contract is broken, our confidence in the entire product just plummets. All right, so now let's switch gears and move into our second world. This world isn't about whether a feature works, but about the experience of using it. We're talking about speed, reliability, security. It's all about how well the software performs, especially when it's under pressure. And this is the domain of non-functional testing. Think of it this way. It's not checking a feature, it's checking an attribute. Questions like, how many people can log in at the same time? How fast does the page actually load? Is our system safe from hackers? These aren't simple pass-fail questions, but man, they are just as critical. And if you think this is just a nice to have, the stakes are incredibly high. Check this out. Research shows that 38% of people will just leave a website if it takes more than 3 seconds to load. 3 seconds. That's the entire window you have before almost 4 out of every 10 of your potential users are just gone. For businesses, this translates directly to money. The same research found that for an e-commerce site, every single extra second of load time can slash your conversion rates by a whopping 12%. All of a sudden, performance isn't just some techie detail, it's a core business metric. It's everything. So, if performance is that critical, how do we actually improve it? Well, this isn't guesswork, it's a science. We can use data-driven techniques to measure and optimize every single part of the system.
Take a look at this chart. It shows the incredible impact of smart system design. Things like caching, which is kind of like creating a super fast temporary memory for data you use all the time, and load balancing, which is like a traffic cop that makes sure no single server gets overwhelmed. Look at those metrics. We are seeing huge drops in response time and massive jumps in user retention. This is literally how systems handle millions of users without just falling over.
And we can get even more detailed, right down to the database itself. This table shows some very specific optimizations. For instance, look at connection pooling. That's just reusing database connections instead of making new ones. It drops the response time to just 14 milliseconds. Or how about data denormalization? Look at that. It gets the query time down to a blistering 7.5 milliseconds. These aren't just tiny tweaks. They are absolute game changers for performance. This chart shows that optimization happens at every single level, even down to how the code is actually running. Look at something called just-in-time compilation. It's a clever way to make code faster while it's executing. The data here shows it can give you a 45% performance boost. Even something as basic as how you handle text can cut your memory usage by over 60%. It all adds up to a much faster, much more efficient system. Of course, with all this incredible complexity, there's a very human side to it all. I love this quote. It just perfectly nails that feeling. That moment when your beautiful, pristine, perfectly tested code meets the wild, chaotic reality of the real world for the very first time. It's this mix of awe and confusion and just a little bit of panic. So here we are. We have these two worlds, the world of making sure features work and the world of making sure the system performs well. The real art of great software development isn't about choosing one over the other. It's about mastering the continuous, never-ending balancing act between them. And this is the crucial point right here. You can't just keep building new features without thinking about how they'll impact performance. But you also can't spend all your time optimizing without ever delivering the new things your users are asking for. True excellence is found right there, in that constant tension between the two. And here's what I think is the ultimate takeaway. How often your team creates those regression bugs, breaking old stuff while building new stuff, that is a direct measurement of your organization's engineering maturity. It shows exactly how well you can innovate and move forward without betraying the trust that your users have placed in you. So, I'll leave you with a final thought to chew on. It is so easy to say your software works, but does it perform? Does it feel fast and snappy and reliable to the person actually using it? Because in today's world, where a few seconds can literally make or break your success, maybe performance isn't just a technical detail. Maybe performance is the feature.